3, trigonometric functions and the unit circles. All right, in the past, what did we do? We found values of trigonometric functions for acute angles. Remember, that means angles less than 90 within a right triangle. Today, we're going to look at finding trigonometric functions for any angle, whether it be acute or obtuse, and doing so with the unit circle. And so first, we're going to use some vocabulary here. Quadrantal angle refers to just when we have different quadrants you might be familiar with. We have different quadrants. Quadrantal angle is just an angle within the quadrant. So said another way, reference angle is what you'll hear me use most often. The reference angle would be the angle that connects to the x-axis no matter which way it's pointing. So like, for example, that one there in red, this would be the reference angle. Or if I had this angle here, what you would do is you would connect the angle to the x-axis, and the reference angle would be the angle that connects it there. It would not be this angle, nor would it be the right angle over here. It would always be the angle that connects the origin to the x-axis. And these would be called also a reference triangle. So not only is that a reference angle, these are reference triangles when you connect them to the x-axis. A unit circle, you're going to see, is a circle that has a radius of 1 unit. Circular function just means it's a function that is circular in nature, or periodic just means it recurs every period or so. A period is a length of time that causes something to repeat itself. So here is an example. They're showing you how we're going to find a trigonometric angle at any location. So this one's obtuse, as you can see here. We'll use the x value and the y value. If you remember, I said psi y cos x, tangent is y over x. Well, they do the same thing here, but instead of saying h, they're going to use r for radius. This is leading us into the unit circle. So they use r for radius, but you could say h there. So it's still psi y cos x, tangent is y over x. The reciprocal functions, obviously, just flip those. Here it's saying the r is equal to the square root of x squared plus y squared. That's the Pythagorean theorem. It would be the same thing if you wanted to use h. You would say h, the hypotenuse, is equal to the x value squared plus the y value squared, and then take the square root. So let's look at an example. It says, let 4, -3 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trigonometric functions of theta. Okay, so this is quite simple once we realize what it's asking. It's saying plot -4, 3. Now this means this is the x value here, this is the y value, and since this is the y-axis, this is the x-axis, -4 would be left 4 units, 1, 2, 3, and 4. The 3 would be up 3. So what we have here is an angle that has a point right there. So you could draw it going through, wow, that is terrible. I'll try that again. As an angle going through that point. But to find the theta, we were going to connect it from over here. So this would be referencing theta here. And so if I wanted to find any of the angles, I could say, well, the sine of that angle is always y over h. Well, so what is my h? What is my y? What I could do here is I'm going to make a triangle out of this, a reference angle. And so I have those values. We can see the x value here is 4 units because it was left 4. So it's 4 units left, and it goes up 3 units. That's how we got that point there, -4, 3. Well, if I wanted to find the sine, I need to find out what h is. So to find my h, I would do Pythagorean theorem. And so h or r, whatever letter you want to use, would be equal to the square root of -4 squared plus 3 squared. And -4 squared is 16. 3 squared is 9. So we have 16 plus 9. So the square root of 25, which is equal to 5. So h is 5 here. So the sine value would be the y, which is 3 over 5. And I can find all the other 6. I'm just going to write them out real quick. We have cosine tangent. I said the other 6. Really, it's the other 5. And then here, the reciprocal is CSE, which means cosecant. And then this one was secant. And this is cotangent. And so, to find my other values, cosine is psi y cos x. My x is -4. And if it's only one value, the silent h is what goes in the denominator, which is 5. Tangent is y over x, so 3 over -4. These would just be the reciprocals, so it'd be 5/3, 5 over -4, and this one is -4 over 3. It does not matter if the negative's in the numerator or denominator. So now you have one. See if you can sketch that and find the other values for that point.